Alright, so this video is going to be on implicit differentiation. So the functions we've been used to differentiating are done in the form of fx is equal to or y is equal to. And then we can simply say f prime of x is or y prime is. That's typically how we find our derivatives and solve for our derivatives. However, there are functions that are defined implicitly with both x and y, meaning x and y are related in some way, but we don't get y is equal to or f is equal to nicely. Take x squared plus y squared is equal to 25, for example, or x cubed plus y cubed is equal to 6xy. Now for both of these functions, we don't simply have y isolated on one side equal to the rest of the function. They're intermixed with x. Now some functions, like the first in particular, are decently simple to solve for and isolate y. However, in the case of functions like the second, it's a pretty complicated process. Now that's why implicit differentiation exists. So you may see the derivative of y defined as dy of dx. For the sake of this video and for simplicity's sake, I'm going to denote the derivative of y in terms of x as y prime. So for starters, we need to talk about how this is going to look in the execution of our problems. Now, the derivative of y is equal to y prime. Now this is different than x, where the derivative of x is simply 1. Right? Now that's what we're used to. Now the importance in this difference lies in the more complicated derivatives of y. I'm going to preface this by saying you must treat any differentiation of y as a chain rule. Now here's some examples. If we took the derivative of ln of x, we know that this would just be 1 over x, right? Now if we did chain rule, it would be the same thing. Derivative of the outside, 1 over x times the derivative of the inside, which is just 1. That's why we don't really have to worry about chain rule when everything's in terms of x. Now for y, on the other hand, if we had ln of y, we would have to do our chain rule. So we'd get 1 over y, so taking the derivative of the outside while keeping the inside the same, so using y, multiplied by y prime. That's the derivative of the inside. Now this translates to e to the x, where the derivative is also e to the x. For e to the y, it would be e to the y times y prime. Derivative of the outside times the derivative of the inside. Same goes for x squared, which we know to go to 2x, whereas y squared, derivative of the outside, so we get 2y times the derivative of the inside, which is y prime. So hopefully you're noticing a pattern, and it's that no matter what you're doing with y, you're going to have to use some chain rule. So let's go ahead and look at the original examples that we had up. The format for solving a derivative when using implicit differentiation is taking the derivative and then isolating y prime, so that we can say the derivative in terms of x, the derivative of y in terms of x is equal to blank. So we're going to do this right now. So we know the derivative of x squared is 2x. Then for y, we're going to have to use our chain rule. So 2y times y prime is equal to now 0. So the format is, if there's any addition or subtraction, you want to make sure to get everything that does not have y prime on the other side. The reason being is so that we can factor out our y prime. In this case, there's only one term that has y prime. So we're going to subtract both sides by 2x and get 2y y prime is equal to negative 2x, and then divide by 2y. Now our final answer is going to be y prime is equal to negative 2x over 2y, which of course would simplify to negative x over y. Now here's where that arithmetic and isolation really comes into play. We're going to do x cubed plus y cubed is equal to 6xy. Now all your traditional rules, including product rule, will be used throughout all the chapters of calculus. So in this case, we are going to end up using product rule, as you can see right here. We have two separate terms multiplied by one another. So we're going to do our regular power rules. So we have 3x squared, our chain rule for y. So we have 3y squared times y prime, the derivative of the inside. Now for our 6xy, we're going to do our udv plus VDU. Haven't made a video on product rule yet, but when I do, that's the format that I do my product rule. If we call one term U, one V, the product rule is U dV, as in U times the derivative of V, plus V du, as in V times the derivative of U. So in this case, we'll just go ahead and put 6 on the outside to make it easier on us. We're going to have our UdV, which is x y prime, plus x will turn into 1, and y will stay the same, so plus y. Now our goal is to get all of the terms that have y prime on one side and all of the terms that don't on the other. So we're going to have to distribute out the 6 to make that happen. So we'll have 3x squared plus 3y squared y prime is equal to 6xy prime plus 6y. Now what I'm going to do is I'm going to subtract 3x squared from both sides and subtract 6xy prime from both sides. This way I'm getting all my terms with y prime on one side and all the terms that don't on the other. So we'll end up with 3y squared y prime minus 6x y prime is equal to 6y minus 3x squared. All right. Now what can we do to isolate our y prime? Well, we have a y prime in two terms, so we can factor it out. So we'll have y prime times 3y squared minus 6x equals 6y minus 3x squared. And then divide both sides by 3y squared minus 6x. So we'll end up with y prime is equal to 6y minus 3x squared over 3y squared minus 6x. And that is our final answer. So let's do some more difficult examples together. So we have x squared is divided by x plus y equal to y squared plus 1. Alright, so let's take the derivative and keep in mind that we are going to have to use quotient rule right here. So once again, I like to use u's and v's for my examples when it comes to anything quotient rule and product rule related. So the derivative of u over v would be v du minus u dv all over v squared. All right. So in this case, our u is x squared. Our du is going to be 2x. Our v is x plus y, and our dv is going to be 1 plus y prime. So what this will differentiate to be, on this side, we're going to use our quotient rule. So we'll have x plus y times 2x minus our x squared times 1 plus y prime all over x plus y squared. Now for the right side, we're going to have to use our chain rule. So we bring down the 2. We have 2y. Multiply by y prime. And that 1's just going to disappear. So what do we have to do to isolate our y prime? Well, we can split up this fraction. And excuse me, I'm going to have to erase some of my work to make room. So please try to follow along. I know it'll be kind of difficult. But first and foremost, we're going to go ahead and distribute out all of our top terms. So we'll have 2x squared plus 2xy minus, so our x squared plus x squared y prime. Now we can distribute out that negative, and voila. That's what we have. So now what we can do is break up this fraction a little bit. And this is where I'm going to have to erase work on top to make room. And I'm just going to start working my way down so that you can see the previous work as I'm moving along. So from here, anything that's added or subtracted to one another in a fraction can be broken up. So we're going to have our 2x squared plus 2xy minus x squared all over x plus y squared minus our x squared y prime over x plus y squared. That's equal to our 2y y prime. Okay. So if we add this to both sides, I'm not going to write it out, but I'm going to add this exact term to this side so that we can isolate our y primes. That's going to be our next step. So we get 2x squared plus 2xy minus x squared all over x plus y squared is equal to 2y y prime plus x squared y prime over x plus y squared. Now this is going to be the same format that we always use. I'm going to go ahead and pull out that y prime, and I'm going to divide this whole side by the exact same thing. So in this case, we can actually simplify this out a little bit, because if we have 2x squared, we can subtract by that x squared right there and just get left with x squared plus 2xy, just to make it easier on ourselves. But all right, so I'm going to pull out that y prime, factor it out, and then we'll be left with 2y plus x squared over x plus y squared is equal to x squared plus 2xy over x plus y squared. Now, all that's left to happen is that we can go ahead and divide both sides by this whole term, and we'll get a really jumbled up looking mess. And there is some ways to simplify it a bit, like if we put this over a common denominator, so multiply the top and bottom of it by x plus y squared, and then when we divide, it would get rid of this whole term. But regardless, you get the idea. We divide by whatever's multiplied by y prime to isolate y prime. Another example. We have cosine. Here, I'm going to write a bit higher so that I give myself some room for work. We have cosine of xy is equal to 1 plus sine of y. So we're going to take the derivative of both sides. So we're going to have to use chain rule. So the derivative of this whole function, we're going to have negative sine of xy multiplied by the derivative of the inside. So in this case, we're going to have to use our product rule. So we're going to have xy prime plus y. Set this equal to, our 1's going to disappear, and we're going to have sine of y. Remember, anything in terms of y, we have to do some chain rule. So it's going to become cosine of y times y prime. Okay. So now the best course of action, whenever you have anything like this, the only way to really isolate our y primes is we're going to have to multiply this out and then take whatever term has y prime in it and get it over to this side. So we'll end up with negative sine of xy times xy prime minus y sine of xy. Set this equal to y prime cosine of y. Now we can add both sides by this whole term. So we're going to add this to both sides and end up with negative y sine of xy is equal to y prime cosine of y plus xy prime sine of xy. Now we can factor out our y prime from both of those terms, get cosine of y plus x sine of xy is equal to negative sine of xy, and then divide both sides by this whole thing. So we'll have y prime ultimately is equal to negative y sine of xy over cosine of y plus x sine of xy, and that is our final answer. Now, when taking and solving for the second derivative, in other words, y double prime, things are a little bit trickier. So let's take 9x squared minus y squared is equal to 1 for an example. Okay, so we're going to execute our first derivative. So we bring down that 2. We're going to have 18x minus 2y prime. Remember that chain rule is equal to 0. Okay, isolate our y prime. So we'll get 18x is equal to 2y prime divided by 2y, and we'll get y prime is equal to 18x divided by 2y, or in other words, 9x over y. Now when we take the second derivative, right, so we know that, I'm going to write it up here, we know that our first derivative is equal to 9x over y. So when we take the second derivative, we'll have to do our chain rule, as always. So we'll get y prime, y double prime, so the derivative of y prime will become y double prime, is equal to our VDU, so y times 9 minus our UDV, so 9x multiplied by y prime, all over v squared. Okay, simple enough. And to simplify it out, we have 9y minus 9x y prime over y squared. Now the issue is that we're left with a y double prime and a y prime, and we want everything simply in terms of x's and y's. So to do so, we must substitute our first derivative in place of y prime. So this is in order to complete the problem. So we have y prime is equal to 9x over y. So we can replace y prime with 9x over y. So we'll end up with 9y minus 9x over y, all over y squared. If you distribute it out, you'll end up with, 9y minus 81x squared over y, all over y squared. But the gist of it is that you cannot have a y prime in your answer. You have to substitute it with the first derivative. Now let's do a couple of practice problems together. Like I've said in previous videos, go ahead and stop the video after I state and write down the problem, and then attempt it yourself, and then you can continue through if you're stuck, or if you just want to see how I did it, don't know if you got the right answer, then go ahead and watch me complete the problem. So for the first problem, we want to find y prime for x plus y squared is equal to x squared. Go ahead and pause the video now and attempt it yourself. Alright, so the derivative of x will be 1. the derivative of y squared, we're going to have to do our outside, so 2y multiplied by the derivative of the inside, so y prime, is equal to 2x. So now let's isolate the term that has y prime in it, subtracting both sides by 1. We get 2y y prime is equal to 2x minus 1. And now divide both sides by 2y to isolate y prime finally. And this should be the answer that you came out with. Next, let's find y prime for 2 over x minus 1 over y is equal to 4. Go ahead and stop the video now and attempt it yourself. All right, so the derivative of this, we know that if you have a variable on the bottom of a fraction, you're going to differentiate it in terms of its exponent, which would actually be a negative exponent. So before we take the derivative, let's rewrite this as 2x to the negative 1 minus y to the negative 1 is equal to 4. So now let's take the derivative. So we'll end up with taking down this negative 1 using power rule. We'll get negative 2x to the negative 2. And then taking down our negative 1 plus y to negative 2 times y prime. So again, it's our outside, so doing our power rule, keeping our y, and then multiplying by the derivative of the inside. This is all equal to 0. Now is around the time where I like to revert our exponents back into fraction form. So we'll have negative 2 over x squared plus y prime over y squared is equal to 0. So we can isolate y prime in the terms with y prime by adding 2 over x squared to both sides. So we'll end up with y prime over y squared is equal to 2 over x squared. And then go ahead and multiply y squared to both sides, and you'll end up with, ultimately, let me go ahead and erase some work to get this answer written out, y prime is equal to 2y squared over x squared. And that should be your final answer. Next, we're going to seek to find y prime for ln of y minus x squared is equal to 5x. So go ahead and stop the video now. All right, so this derivative, so we know that ln of y, right, ln of x typically becomes 1 over x. So ln of y would become 1 over y for the outside, and then derivative of the inside, so multiplied by y prime. I'm going to go ahead and save some time and just put it on top. Now minus 2x is equal to 5. So we're going to go ahead and add 2x to both sides to isolate our y prime. We'll get y prime over y is equal to 5 plus 2x. And now you can multiply y to both sides, and we'll get y prime is equal to 5 plus 2x times y. Now lastly, we're going to try to find our y double prime of this next one. So we have 2x squared minus 4y, wrote x, minus 4y plus y squared equals 4. So go ahead and stop the video now and give it your attempt. All right, so this derivative, we'd use our power rule, so we bring down, we have 4x, then we're going to have minus 4, and y is going to become y prime. And then for our y squared, outside inside, so 2y times the derivative of the inside, which is y prime, is equal to 0. Now we got to isolate our y primes by subtracting by 4x. We'll end up with negative 4y prime plus 2y y prime is equal to negative 4x. Now we can isolate our y prime by factoring it out. And dividing by this term. So we end up with negative 4x over negative 4 plus 2 Now I'm going to write this on the side so that we remember, because we're trying to take the second derivative here. Okay. So we know we're going to have to use quotient rule. So our u is going to be our negative 4x, so our du would just be negative 4. Our v is going to be our negative 4 plus 2y, so our dv is just going to end up 2y prime. So using that information, we have negative 4 plus 2y multiplied by negative 4 minus our negative 4x times 2y prime, all over minus 4 plus 2y squared. And our y double prime is equal to this here, because we differentiated the left side and it became y double prime. So now we can simplify this out a little bit just to make it a little bit easier on the i's. So we'll get positive 16 minus 8y. That is going to be plus 8xy prime, all over our negative 4 plus 2y squared. So now, like I've said previously, we cannot leave this answer with a y prime. So we're gonna have to go ahead and substitute in this y prime value in for our final answer. And it will not look pretty, but it will be the right answer. So instead of y prime, we're going to have our negative 4 over negative 4 plus 2y all over negative 4 plus 2y squared. Hope you enjoyed. Good luck.